I'm going to give a general and color theory lecture about all the things that I haven't gone over in the individual assignments. This is kind of just an overview of just color theory, stuff that I normally discuss in class, but we don't have that option here. So this is the first thing I always want to show students is different ways the colored light you're using affects what you're looking at. So at the top you see same piece of white paper being held in daylight, and in the middle it's under incandescent light, which is kind of like the old-fashioned screw-in light bulb, and then at the bottom it's under fluorescent light. So you can see the incandescent light is very warm. It leans towards the warm side, and then the fluorescent, it's a little more cool. And daylight is kind of, at least they say, it's like the full spectrum, so it's the most balanced light. You can always, there's some, if you go into some art stores, they'll even have like a light you can buy that'll have like an incandescent light in the middle, and then it'll have like a ring of fluorescent light on the outside. So it kind of, the idea is it balances both of those. But one thing that I want you to know is that the lighting that you're sort of working in affects how you see things. Um, make sure, I think sometimes it helps to check your art, with some daylight, so you know that you're not skewing it to the warm or to the cool. And this is kind of the basic idea of what we're thinking about with color is, so this is just a yellow, and it's a full spectrum of a yellow. And on one side, say like the left side, it's leaning towards the orange, and on the other side it's leaning towards the green. And you kind of want, whenever I'm talking about yellow, like the primary yellow, I think of this right here, like something that doesn't feel like it's leaning towards the green, something that doesn't feel like it's leaning towards the orange. It's perfectly like a balanced yellow. And when you're painting, you kind of need um, all types of yellows. You need a yellow that's kind of orangey, one that's kind of neutral, one that's kind of green. Um, the numbers at the top are, it's the nanometers, so it's like it's literally a wave. So color is literally, it's a wave, and when you measure like the peak and the trough, it'll literally be in nanometers. So you can see if it gets bigger, apparently it's more towards the red, and as it gets smaller, it's towards the violet. And this is all the in betweens here. So you can see as it gets smaller, it gets towards the orange. Actually, when it gets smaller, it goes towards the green. Larger, it gets towards the orange. So this is something that you've all probably seen before. So white light, when you break it up, it's it's a full spectrum of colors. Um, and it's good to sort of just keep this in mind, because you have to sort of to some degree know what you're looking at. So if, say this is supposed to be like a yellow wall, and when white light hits it, so that's what this rainbow is representing. White light, say from the sun, hits the yellow wall. What is happening is most of the colors from the spectrum are being absorbed by that wall, and it's not absorbing the yellow. So the yellow wavelength is what's being bounced back towards your eye. So that's sort of conceptually what's going on when you're looking at colored objects. So let's just start with a definition as we move into the basics of the color wheel here. So primary color, so it's any, what does it say? Group of color from which all other colors can be obtained or mixed. So yeah, so it's the ones that you basically can't mix. It's like all the other colors can be mixed from the primary colors. And we're going to see there's lots of problems with the concept of primary colors in the color wheel. I'm going to go over them. So here's what we've been looking at in class. This is it's like a, they call this a red, blue, yellow color wheel, and it's called that because those are the primaries in this color wheel. The problem is, and this is how I learned color theory. Like I learned from like my color theory class that I had when I was in art school. It was mostly the teacher was following the Elements of Color by Ittens, which I've shown you the book. in class. It's the one that we sort of copy the star from. And he uses this color wheel, which is the red, blue, yellow color wheel. Problem is, it doesn't have the magenta, the cyan, has the yellow. It's not that big of a problem, but it's a minor problem that you have to be conceptually aware of. So let me clarify what the Itten's color scheme is. So his primaries are here. This is in the middle. It kind of shows it in reverse. You have the primaries here, and you mix these two to get the secondary, and then same thing here. Mix these two, you get the secondary, and then the idea is you can get every color. So here's how it's broken out: primary, secondary, and then tertiary. So you can mix orange and red, you can get the red orange, you get the idea. And it has this kind of idea that it's all encompassing, but then the problem is, and I learned this from working in Photoshop, which is in Photoshop you see this color gamut thing. I don't know, this is from like older folders Photoshop. I don't even know if they have this anymore, but I would see because Photoshop is also keeping in mind printing, and printing is aware of the cyan, magenta, yellow color primaries. So I would always see this, and I kind of just knew from years of working in Photoshop that magenta is your pure primary. Lemon yellow, cyan is pure. So the idea is red, which is like over here, isn't really primary in the sense that it's not unmixable, because you can mix red. You take magenta, add a hint of yellow, and you have red. So the idea with the primary, it has to be unmixable, it has to be primary. And the problem with the Itten's color wheel is that red technically is not unmixable. And same thing with blue, because the Itten's has the blue, which is basically cyan with a hint of magenta. It doesn't go full on into like ultramarine blue, where it's a little violety blue, but it is a hint of red in it. So it's not a pure, undiluted blue. And that becomes a problem when you start to, and you probably think, well, so what? Who cares? Well, it becomes a problem when you start wanting to mix colors. Let's say you have a color and you don't want any of the complement to sort of taint it. So like if you have a blue and it isn't a pure cyan blue, let's say you have a blue that's leaning towards the red. It's like, say, over here, and you decide, oh, I want to kind of add a hint of green to my blue to get a turquoise. The problem is if you use like an ultramarine blue and you throw in some green, those are almost complements. So they're going to start to gray, and you're not going to get a very pure turquoise. So you would have to start with a completely pure blue, which would be cyan. You throw in a little bit of green, and then you'll get your turquoise. So here's the two color wheels side by side: the red, blue, yellow. Which that's what we've been using. And that's what I've been showing in class, because that's the one that I have to show you, and it's one you go to any art supply store, you'll get that color wheel. And here's the cyan, magenta, yellow one. They're not that different. Like, because to me, I use these all the time. I just conceptually imagine right in here I have my my magenta. Oops, skipped ahead accidentally. And then I think like right in here is where I have my cyan. And then yellow's still there. So you can see it. Here's yellow, cyan, and your magenta. And I didn't show I deliberately didn't show you this because it'll throw you for a loop when we're doing the last assignment. Because here's what this is the complementaries right here. But everything kind of shifts around a little bit when you're in the cyan, yellow, magenta territory. The complements aren't quite the same. Over here you got blue, orange, but here you got like ultramarine yellow. It's like it's different. Like the complements are different. They're not that different. They're just a little different. So you can see over here you have red, cyan. Here you have red, green. Red, green. Here you have red, cyan. It's because we have an extra color thrown in. It's everything kind of shifts around when you're using this color wheel because you have um, purer colors, and so the relationships are different. When I'm painting, I tend to think of this more than I think of this, but again, it's not they're not that different. Like if I had a cyan and I wanted to say mix in its complement, I probably would pick um, like a warm kind of fire engine red, as opposed to if I was over here, if I had like a blue, I wouldn't necessarily think of orange. I would think more over here. It's just slightly different. Everything's just slightly shifted over. I do find for color mixtures with paint that this one's a tad more accurate to follow. And I'm going to show you how this one is less accurate and this is more accurate in the sense that it corresponds to the way our eyes work. So let's do this little exercise together. So stare at that dot in the middle and put your face close to the screen and stare at it for a good 20 seconds here. Let's just stare and try not to move your eye around. And then I'm going to show you an after image, and I want you to tell me what colors you see in the after image. It should be the complements that are based off of the cyan, magenta, yellow color wheel. So keep staring, 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 stare. Try not to move your eye around. And I'm going to switch to white, and you're going to see an after image. Keep staring. So blink, blink, blink. You should see a cyan in the top corner and a magenta next to it, yellow, and then at the bottom row you'll see a red and a green and a bluish one. This is what you should see. That's what the after image should look like. So you can see it's the opposite of all these. Everything flipped. So it's confusing because the red was here, but then you saw cyan. Green was here, but you saw the magenta. So it's basically what's going on is your eye is getting sort of exhausted. Your eyes being sort of overwhelmed by staring at this one color, and then once it kind of stops seeing that color, the opposite um, shows. It's like the opposite of your eye compensating to sort of it's sort of like if you were to hold a really heavy weight for a really really long time and you let go of the weight, all of a sudden your arm feels really light. It's like the opposite happens. Um, it's like your eye gets exhausted and then it starts to see the opposite color. So that's kind of proof that this is the color scheme that's more accurate because it relates more to our sort of actual biological eye. And what I would say because it relates more to actual the way light works.